Welcome to OppsCoder, your daily source for software engineering news. Today we are looking at an exciting new update: Stop Calling Everything Impostor Syndrome, the myth of just push harder. According to the original post, posted on August 4th, applies an engineering mindset to personal growth. Not everyone who doubts themselves is suffering from imposter syndrome. Sometimes the real problem lies in the strategy they've chosen. This development introduces important changes for developers, software architects, and the broader IT industry. As technology evolves, staying ahead of the curve is more important than ever. We've seen a massive shift in how software is built, tested, and deployed, and updates like this one underscore the rapid pace of innovation. Whether you are working in front-end frameworks, back-end microservices, or cloud infrastructure, understanding these shifts allows you to make better architectural decisions. Let's dive deep into what this means for the ecosystem, starting with the front-end architecture. In recent years, the push towards component-driven design and server-side rendering has reshaped how we deliver content to users. Frameworks like Angular, React, and Vue are constantly evolving to provide better performance, smaller bundle sizes, and improved developer experiences. When a new update drops, it often brings changes to state management, hydration strategies, or routing paradigms. Adapting to these changes requires a thoughtful approach. You cannot simply rewrite your entire application overnight. Instead, you need to incrementally adopt new features, ensuring backwards compatibility and rigorous testing. Moving down the stack, let's talk about back-end microservices. The days of the massive monolithic applications are largely behind us, replaced by distributed systems that offer scalability and resilience. However, this architectural shift introduces its own set of complexities, such as service discovery, distributed tracing, and eventual consistency. When integrating new developments like the one we are discussing today, back-end engineers must consider the impact on network latency, data integrity, and API contracts. It is essential to implement robust error handling, circuit breakers, and comprehensive logging to maintain system health. Furthermore, the rise of serverless computing and managed cloud services has allowed developers to focus more on business logic and less on infrastructure management. AWS, Google Cloud, and Microsoft Azure continue to release tools that abstract away the underlying hardware. But this abstraction is a double-edged sword. While it speeds up development, it also requires a deep understanding of cloud pricing models, security configurations, and vendor lock-in risks. Updates in this space often mean new ways to optimize costs or improve security posture, which are critical metrics for any engineering team. Let's not forget the role of DevOps and continuous integration. The pipeline from code commit to production deployment is the lifeblood of modern software delivery. With the advent of infrastructure as code tools like Terraform and Pulumi, we can now version control our environments just like our application code. Any new technology trend must seamlessly integrate into these CI/CD pipelines. If a new framework or tool breaks your automated testing or deployment scripts, the productivity loss can be significant. Therefore, evaluating the tooling ecosystem surrounding a new update is just as important as the update itself. And of course, we must address the elephant in the room: artificial intelligence. AI is no longer just a buzzword, it is actively transforming the daily workflow of software engineers. From AI-assisted code completion tools like GitHub Copilot to advanced static analysis and automated bug detection, machine learning models are becoming indispensable. The integration of AI into our development tools means we can write code faster, but it also means we must be more vigilant about code review and security. AI models can generate plausible-looking code that contains subtle bugs or vulnerabilities. Understanding how to properly prompt these models and review their output is a new skill that every developer must master. Moreover, the intersection of AI and traditional software engineering is creating entirely new categories of applications. We are seeing a surge in agentic systems, vector databases, and retrieval-augmented generation architectures. For developers, this means learning new paradigms. You need to understand embeddings, similarity search, and prompt engineering alongside your traditional relational databases and REST APIs. So, how do you practically apply all of this information to your current projects? The key is continuous learning and measured adoption. Don't chase every shiny new tool. Instead, evaluate how an update solves a specific pain point in your current architecture. If an update offers a significant performance boost or reduces developer friction, it might be worth the investment to upgrade. Always start with a small proof of concept. Isolate the new technology in a non-critical microservice or a feature branch. Gather metrics, assess the learning curve for your team, and then make an informed decision about wider adoption. Remember, the goal is not to use the newest technology for its own sake, but to deliver reliable, scalable, and maintainable software that provides value to your users. To summarize, today's update is just one piece of a rapidly moving puzzle. By understanding the broader context of front-end evolution, back-end distributed systems, cloud infrastructure, DevOps pipelines, and AI integration, you can position yourself and your team for long-term success. We encourage you to experiment with these new concepts. Build a prototype, read the official documentation, and share your findings with your colleagues. The best way to learn is by doing. It's crucial for engineering managers and individual contributors alike to evaluate how this fits into their current stack. Are you ready to dive in and try it out? Let us know in the comments how you plan to implement this in your own projects. Thank you for tuning in to OppsCoder. We are committed to bringing you the most relevant, deep dive analysis of the software engineering landscape. Stay ahead of the technology curve, keep building amazing things, and we'll see you in the next daily tech update.